Hey guys, I'm back. Can't get rid of me. Sorry. Make sure you hit like and subscribe. Anyway, so today we're just going to talk really fast about the rock cycle. This is for AP, but it might be beneficial to you if you are not in AP and just studying earth science or geology. This stuff is really cool. Do you know science is cool? It is. Anyway, so all the rock on Earth is recycled. This is a super slow process that happens. I mean, again, a lot of these processes are slow in our lifetime, but this is like the slowest of Earth's processes. So you can look right there about what we're going to cover today. Hydro homies, we drink water. So there's three major types of rock: igneous, sedimentary, metamorphic. They're recycled very slowly. And how does this happen? They get weathered and eroded away. They can get melted, and they can get changed, like squeezed and heated through metamorphism. I wonder what type of rock that is. We're going to find out. Okay, so the three main, we'll get to that. But let's talk about rocks and minerals. Boy, it takes me back thinking about this kind of stuff, to be honest. So a mineral is an element, like a single element like carbon, or an inorganic compound like quartz that you can find in the Earth's crust. Usually these are crystalline solids. So what does that mean? Because that sounds kind of too advanced for me. A crystalline structure is when you have the atoms arranged in a certain pattern. So halite is a mineral. Guess what that is? Salt. And if you have salt at home and like anything where you can kind of zoom in really close to it, you'll see that salt is in these little, that's not a very good cube. Whatever, it's in like a little cube. So they're little blocks. Why is that? Because the sodium and chlorine atoms inside that piece of halite are arranged in like a giant cube. So because the atoms themselves are arranged that way, then when we look at halite, it's going to break and fracture in a cube shape. And so it's going to form these tiny little cubes. It's how it's going to break. That's also why you can have something that like it forms into like a literal crystal shape. That's how the atoms are arranged. Or sometimes the atoms are arranged in flat sheets. That's how you can get something like mica, which it's super fine, thin sheets. And then a rock is just a combination of one or more minerals. Easy. Just wait until you get to identify rocks and minerals. Not as easy. Not as easy as this. So what are the main types of rock? You've probably heard this before, or if you're hearing it for the first time, you're learning something. I don't know how you found me to learn this the first time, but here you are. So sedimentary rocks come from sediments. You don't say. Yeah, they really do. So what's a sediment? So when you have a piece of rock and it's getting broken down by water or wind or plants or even chemicals like acid rain, pieces break off. So you can call that sand or a pebble or dirt. That's a sediment. So they get weathered, broken down, and eroded, moved away. And they could also be plant and animal remains. So these are the types of rocks we find fossils. So these sediments are eroded. They're moved by wind, water, gravity, etc. And they get deposited in layer after layer after layer. So think of like a stream or a river coming down a mountain. And every spring you have this huge rush of the melting glacial meltwater. Melting meltwater, cool. But anyway, with it, it's going to carry like any animal that fell in or was frozen. It could carry like mud and sand and pebbles, and it's going to end up out at the bottom where it starts to like slow down, and it's going to deposit, and all that stuff is going to settle. Well, then it happens the next year, and the next year, and the next year, and then it happens for thousands of years, and those layers get buried and buried and buried, and over thousands of years, they'll cement and form into rock. So some typical examples of sedimentary rock is sandstone, shale, dolomite, limestone, lignite, bituminous coal. My favorite is conglomerate because it just looks like a big mass of like shells and rocks and stuff. It looks like concrete or cement. Here's a cool thing about limestone. You can identify it really easily. It's white. It's not the only white rock, but if you put vinegar on this rock, it will start to bubble because of the high calcium content in limestone, which is also why if you see old tombstones that are made of limestone, they're so smooth and like the words are fading away. It's because it's being weathered by like acid rain and by chemicals. All right, so then we have igneous rock. Where are you? Where are you, igneous rock? I have one. Not yet. So igneous rocks are formed from the cooling of liquid hot magma or lava. Okay, so magma is lava underground, so it's liquid rock underground, and then once it pops up on the surface, we call it lava. Scientists just like to have names for everything specifically. So magma is under the earth, lava is on the earth, but it's the same stuff. So when that magma or lava cools, it can form into rock that we call igneous rock. A common igneous rock is granite. Now, what's really cool is you can tell how quickly or slowly this igneous rock has cooled, because as the rock cools, the minerals that are inside will crystallize. Remember, like these, they have this crystalline structure, usually some of them. So when you look at granite, you can see these grays and whites and pinks. Those are like little mineral crystal grains that have formed and cooled. So that granite cooled slowly over thousands of years and allowed these crystals to form. Something like basalt, which is just kind of smooth looking black rock, that cooled very quickly. Like you'd see that on the side of a volcano. You'd see that in Hawaii. If it cools insanely quickly, you can get something like obsidian, which like looks like glass almost. Or you can have ejecta. There's lots of fun words for stuff. And I'm pretty sure that this type of rock is called pyroclast, or it's a pyroclastic rock. My friend gave this to me. Thank you, dear friend. If you ever see this, I'll just tell you. But he went to Iceland and got me a rock from a volcano. Hopefully you can kind of see that there's a bunch of little holes in this. So this was some liquid hot magma that got tossed through the air and was cooled. And so you can see these kind of holes that are in there. So that's another type of igneous rock. And then, I don't know, I can't decide what my favorite type of rock is. I think I like sedimentary because it can be from living things. But I think I also really like metamorphic rock. I think I've always just liked the different metamorphic rocks. So any rock that already was there, igneous, sedimentary, or another metamorphic rock, can get subjected to high temperatures and pressure. So maybe it's part slowly. Remember, these things happen slowly, but maybe it's on like a plate that's being subducted and pushed down. And then maybe the earth shifts and it gets pushed back up again and we can uncover it. But so as it's getting subducted, it's squeezed and pressed under like millions of tons of rock. And it's getting hot because it's getting close to the mantle. It's in the lower lithosphere, getting close to the asthenosphere. And then maybe it gets pushed back up. So all that's going to make it like the rock act like kind of like Play-Doh, sort of, where it's going to take it and squeeze it and stretch it. So if you have a sedimentary rock that's got those nice layers, you can see the layers sort of like the bands are kind of wavy. So that's metamorphic rocks are pretty cool. You can have anthracite, sorry, I can't talk, slate, marble. My favorite metamorphic rocks that I list on here are gneiss, which is not spelled N-I-S-E, it's G-N-E-I-S-S. I'll show you later. And schist, because it's a funny word, but those are my favorite metamorphic rocks. Do you have a favorite metamorphic rock? Look one up. Have a favorite. It's fun. It's fun to tell people, oh yeah, my favorite rock. And people will look at you like they look at me, like she's crazy. I mean, yeah. So, like I said before, rocks are recycled very, very, very slowly. It's the slowest of Earth's cyclic processes. Like, you've got the water cycle, you've got the carbon cycle. This is just a very, very slow cycle. So let's look at a big picture of that. Now remember, it's not a perfect circle like this. Good band. Very early 2000s. Anyway, it's not a perfect circle like that. In fact, you can have this igneous rock continually melting and reforming into igneous rock. You can have sediments that get weathered and eroded and become new sedimentary rock. You can have a metamorphic rock that gets pushed and squeezed and gets then pushed back up and then comes back down. You can have a sedimentary go to metamorphic and then go back to sedimentary and then go to igneous. There's not a specific order to this cycle like how it appears in this picture. In fact, there should be a lot more arrows going back and forth and flying all around, but sometimes those pictures are a little bit busy. So I want to make sure you understand that it's not like it has to go in this direction or that direction. It can stay there. A rock can be around for millions and millions of years. It eventually will pop back into the cycle and change, but it doesn't have to go in this perfect cycle. So let's just make sure that you kind of review and understand how these rocks are formed. We have liquid hot magma from the mantle, push up through the lithosphere, and it can come out through a volcano or kind of through a fissure and cool quickly or slowly and form your igneous rock, formed directly from liquid rock. Then let's say that rock is up here on the edge of the volcano. We'll get broken down. It will get weathered. Weathering is the breaking down of rock, and erosion is the movement of weathered rock. So it will break down a little bit. It will get moved, and then it will get deposited, and then it will form into these layers after time. Okay, it takes a long time. And if that stuff has been in layers for months, it doesn't mean it's a rock. It will take years and years and years. And then if it gets subjected to heat, pressure, and stress, then it will become metamorphic rock. So sedimentary rock, that's the only rock where you can find fossils. Why can't you find it in metamorphic rock? I mean, there could be some fossil that got metamorphed. Is that the right word? Anyway, but how are you going to know what it is? If it's been squeezed and stretched, it's not useful anymore. And if it gets all the way melted, well, it's gone. All that biological material is gone, and all those impressions are gone. So you can only find fossils in sedimentary rock, which, if you think about it, isn't that sad? How many animals are going to form? How many plants are going to form into a rock and get trapped? Not many. Can you imagine all the really cool animals and plants that existed that we'll never know of? It almost makes you sad. It makes you wish you could take a drone and fly back 250 million years ago and just take pictures and see what the living things look like. Does anyone wish that beside me? Can some genius invent that or something? Get that alien technology going. Someone. I want to see dinosaurs. Okay. I'm feeling weird. It's a Friday. Should be feeling good. So I hope that helps you with your knowledge and understanding of the rock cycle. Next, we got to figure out how rocks turn into soil. But that's got to be its own video. I know. You're getting excited already. I actually got to go dig out some soil so I can show you. All right. I will talk to you later, and I'll see you soon. I hope that helps.